Hello and welcome to the GCSE Quantitative Chemistry topic with Mrs. Castanera here. We will be going through the foundation tier aspect of this module first with lessons 1 and lessons 2 before moving on to the higher tier booklet with a further 3 lessons. So you'll notice as we go through this booklet that we have the usual knowledge organiser. Okay, so all about quantitative chemistry. Make sure you pay attention to the sections that are labelled as higher tier. For example, here we have this section here. It says higher tier or HT only. There's a few sections like this. Please be aware that those sections you don't need to know if you are only doing foundation tier science. So there's a couple of pages of these knowledge organisers before we get to the self-assessments. Now, as we go through the topic, through the booklet, you'll be able to do more and more of these, and these you should be using before your exams, and they come with helpful links to revision websites. So, what we don't have in here that you will need a copy of, and if you don't have one, please do email your teacher or contact school. You will need a copy of the periodic table of elements, okay? It looks ideally like this. It should have the atomic symbol, such as H for hydrogen, the relative atomic mass, sometimes at the top, sometimes at the bottom. In this one, relative atomic mass is at the top. I recommend getting the same as me so you don't get confused. So your relative atomic mass should be at the top. And the atomic number, the proton number, should be at the bottom. Now for hydrogen, those numbers are the same. If we look at other elements, those numbers are not the same. So you will need a copy of the periodic table of elements for this module. You cannot do the work without this copy of the periodic table, without a copy of the periodic table. So we're going to move on to lesson 1, the mass of atoms. So lesson 1, mass of atoms. You'll need your highlighter at the ready, as well as a pen of at least 2 different colours. Okay, so our keywords for today's lesson are atomic mass, protons, neutrons, mole, percentage and relative. And this here is the content that we'll be covering from the specification. Okay, so this just details what we're learning because it's in the specification. So I'd like you to start by having a go at the knowledge check questions, please. There are 8 questions. Okay, I'd like you to pause the video whilst you attempt those. Okay, so let's go through those. Question 1. Name the smallest subatomic particle of an atom. That would be the electron. Make sure you're ticking and marking in a different colour, and if you get it right, you can tick. If you don't get it right or you only get it partially right, then make sure you're annotating the correct answers or the partial part of the answer you didn't get. Question 2. Name the 2 subatomic particles found in the nucleus. That's the proton and neutron. You need both for the mark. Give the overall charge of an atom. Well, atoms are neutral. If they are not neutral, they're called something else. Those are ions. Name the 2 subatomic particles that are similar in size. That's a proton and a neutron. Question 5. Describe what atomic number tells you about an atom. Now don't worry if you didn't know this one, because this is something we'll be doing this lesson. We have briefly done it in Key Stage 3. So what it is it's the number of protons or also the number of electrons in an atom. So if you said it's the number of protons in an atom or the number of electrons in an atom, you can have the mark. Question 6. Describe what mass number tells you about an atom. Again, this is something we did briefly at Key Stage 3, but it's also a GCSE content item, so don't worry if you didn't know it. So the mass number is the number of protons and neutrons added together, so protons plus neutrons. Question 7. Name the subatomic particle that has a negative charge. That would be an electron. Question 8. Name the subatomic particle that has a neutral charge. Well, that would be a neutron. Okay, so give yourself a mark out of 8, please. Okay, and then we're going to move on. Okay, so today we are going to be able to calculate the relative formula mass of a compound and the relative atomic mass of an atom. So by the end of the lesson we should be able to do this. We're going to calculate the percentage mass of an element in a compound. Okay, so the mass of atoms. Atoms are so small that we don't actually have scales that are sensitive enough to measure their mass. Okay, because atoms are really, really small, tiny. At the same time, we don't have scales that can measure the mass of a planet because it's too big. Okay, so we use something called a relative scale. Okay, now a relative scale relies on comparisons between the sizes of things. So this relative scale allows us to compare the mass of atoms without actually having to measure them. So we use the mass of carbon as the reference point, and we compare all the other atoms to it. The relative atomic mass of carbon is 12. Okay, and so everything else is compared to this. The number 12 comes from the fact that the nucleus of carbon contains 6 protons and 6 neutrons. It also has 6 electrons, but these are so small, okay, that they are insignificant when calculating the total mass. Okay, so we don't look or consider electrons to have a mass. Okay. So the atomic mass of an atom is the total number of protons plus neutrons in the nucleus. Different elements have different sized atoms, which is identified by the mass number. As you read along the periodic table, the mass of the atoms increases. We use AR, with the R being subscript and the A being capitalised, to represent relative atomic mass. Okay, so before we watch this video, we're going to make some notes based on information in the higher tier booklet. Now, if you're a higher tier student who has a higher tier booklet, the notes we're looking at that we're going to be doing are on page 6 of the higher tier booklet, which is lessons 3 onwards. This is lesson 3. If you are a foundation tier student, there are some key content in this higher tier booklet that is also foundation tier, and I think explains these key concepts that we've just reviewed more clearly. And we're going to write these on our notes page. So the student notes page for lesson 1 is on page 12. So turn to page 12 if you're a foundation tier student, and turn to page 6 of the higher tier booklet if you are a higher tier student. So here we have this lesson 3 from the higher tier booklet. It's the first lesson in the higher tier booklet, lesson 3 overall. And it gives us some really nice, really clear definitions. So the first one is AR, and you'll need to write these out if you're a foundation tier student. So AR, the relative atomic mass of an atom is the mass of the nucleus, which is protons and neutrons. So the relative atomic mass is the mass of the nucleus, which is the protons plus the neutrons, and it's stated in the periodic table. Atoms have different AR because they have different quantities of protons and neutrons. Then we're going to talk about the MR, okay, the relative molecular mass, MR. So again, capitalised M, subscript R. Molecules are made from more than one atom chemically combined together, a molecule being something like water, for instance, which is hydrogen and oxygen together. And therefore, to calculate the relative atomic mass of a molecule, we simply add the individual ARs together. So, to calculate the relative atomic mass of a molecule, we add together the individual ARs. For example, water is 2 hydrogens, each for 1 each, so 1 plus 1 for the hydrogens. And the relative atomic mass of oxygen is 16, so we add them all together to give us 18. And as I said earlier, you need your periodic table to help you with this. And as you can see, relative atomic mass here at the top for hydrogen is 1, and for oxygen is 16. And you can see that actually over time these increase as we go along the periodic table, each row beneath being bigger numbers than the last because the elements, the atoms, are getting bigger. Okay. So there's one more thing I want us to write down, okay, and that's the law of conservation of mass. Okay, so there's quite a lot to this sentence, okay, this is really, well, these sentences, but this is really key content, so I do want you to write this down as well. So the law of conservation of mass states that no atoms are lost or made during a chemical reaction. So no atoms are lost or made during a chemical reaction. So the mass of the products equals the mass of the reactants. Okay, so sometimes when we do an investigation, it looks like it does change mass, but actually that's usually a reduction in mass, and that's because gas escapes. So sometimes it might appear to show a change in mass, but actually it's just a gas escaping, okay? Or sometimes a gas, if it increases, a gas is being added, and these gases are coming from the atmosphere, so the surroundings, so they haven't been counted on the scales originally, or they're being lost to the surroundings, and so at the end they aren't around anymore to be counted on the scale. Okay, so I want you to write these 3 definitions down on your student notes page. Okay, if you are a foundation tier student, if you're a higher tier student, you need to highlight this as shown and learn them. These are really essential. Everybody needs to know these 3 definitions. They are essential. They love to examine you on them. Okay, this is easy ways to get marks. Learn these. Nothing difficult to understand. You just have to be able to know it. So pause the video whilst you do that, and then we're going to go back to our lesson. So back to the lesson. There's this clip here on YouTube which I'd like to watch, and it says, with teacher support, make notes of examples of how to calculate the relative formula mass of a substance. Well, I want you to watch it. You can make your own notes, okay, and then we'll go through how to do this in a moment. So I want you to watch this video and then pause this. So pause this video that you're watching now so you can go on YouTube and watch that video. So that's as zoomed in as I can get the link. If you have a digital copy of this booklet, you will be able to click on the link there. So what I'd like us to do before we move on is just add a little note here to say see student notes page. Okay, and that will remind you that there's more information on this notes page. So we're going to move on. And again, the mass of molecules, we have a better explanation on our notes page, which was page 12. Okay, so task 1. Using the periodic table, complete the table below to show the relative atomic mass, AR, of the following elements. Now, we have our periodic tables here. I'm going to move this up so we can see a bit of the periodic table. So, using my periodic table, we're looking for the relative atomic mass of hydrogen. So, you can see here that relative atomic mass is the top part, the number above the symbol. So, the number above hydrogen is 1. Okay, which means my relative atomic mass for hydrogen is 1. So, we're going to fill that in. Okay, so that's 1. Now, see if you can figure out the number for helium. Pause the video whilst you do this, and then we'll mark this one together. Okay, so hopefully you figured out that the relative atomic mass for helium is 4. If you did, well done, tick it. So the way you should have done that is you've looked at helium, the number above helium is a 4. Okay, that's the relative atomic mass. Okay, so we can do this with lots of the elements here. So we're going to pick one that's not on this list. So we're going to look at nitrogen. Now, as you can see, nitrogen is here, it's this one, and it's got 14 above and 7 below. So its relative atomic mass is the bigger number. So the relative atomic mass of nitrogen is 14. Relative atomic mass is always the bigger number because it's protons plus neutrons. Okay, so what I want you to do is use your periodic tables to complete the rest of this. Okay, the rest of this table. Pause the video whilst you do that. Okay, so now that you've completed that, here are the answers. So the relative atomic mass for each of the elements, we've already done hydrogen at 1 and helium at 4. Lithium was 7. Carbon was 12. Oxygen, 16. Chlorine, 35.5. Now there's a reason for it being not a whole number, and that's because there's more than one type of chlorine, and some of them have 35 and some of them have 37, okay, as their relative atomic mass. So the average of these, bizarrely, is 35.5, even though the average of those two numbers is not 35.5, it's 36. The average we give it is 35.5 because there's a lot more of the type of chlorine that way it has a relative atomic mass of 35, and a lot less of the type of chlorine that has a relative atomic mass of 37. So 35.5, if you put that, is correct answer. Magnesium, relative atomic mass is 24, sulfur 32, and calcium is 40. So well done if you got those right. If not, go back through your periodic table and see if you can figure out how we got to the correct answers. Okay, we're going to move on to task 2 now. Okay, so this is the MR, the relative molecular mass. Okay, now remembering, so the relative formula mass, remembering that for this one you have to add up the relative atomic mass, which is what we find in our periodic table. Okay, so you've got to add these up for each of the atoms in the molecule. So H2, which should be written with the 2 here, not there. Okay, now H2. So there are 2 hydrogen atoms, and we know from our previous example, okay, that hydrogen has a relative atomic mass of 1. So for H2, where there are 2 hydrogen atoms, we have to add 1 plus 1 more, because there's 2 of them. So 1 plus 1 gives us 2. Now this time we're doing oxygen, H2O, and I'm sorry about the way that these have come up on the printout. So this should be written H2O, like so. Okay, now again we can use the numbers above us to help with this from task 1. So hydrogen has a relative atomic mass of 1, but there are 2 of them, so that's worth 2. And then oxygen has a relative atomic mass of 16. So to work this out, we're going to be doing 2 plus 16, okay, and that is going to equal 18. Okay, so let's have a look at carbon dioxide. So it should be shown as CO2 like so, not with the 2 down here. Okay, now you need to work out the relative atomic mass of carbon, it's just one of them, and the relative atomic mass of oxygen, and you need to add 2 lots of oxygen. Okay, so the relative atomic mass of carbon is 12. So for this, it's going to be 12 for the carbon, plus 2 lots of oxygen, which is 16. So plus 16, I'm going to move this down so you can actually see what I'm writing. So 12 plus 16 plus 16. So that's carbon plus oxygen plus oxygen. And the good news is that in science, you are always allowed a calculator. So feel free to use a calculator to do that if you're not confident with your maths. Okay, otherwise, you can just carry on. Okay. And so you should be able to add that up, and the number here is 44. Okay, now these do get gradually trickier, so I'm going to go through what each of these is. So this is CH4, we also call, there we go, that's how it should be written here. NaCl, okay, well ideally we'll have written NaCl all in a row like that. MgCl2, so that's magnesium, one of them, and 2 chlorine atoms. S8, so again, ideally the 8 is written here, not down here, so there are 8 sulfurs here. Al2, so that's 2 aluminium, and O3, that's 3 oxygen, and it's all one compound. Okay, so it's Al2O3. And here, this last one, which is very tricky, okay, it should ideally be written as Mg for magnesium, and then we open our brackets, and it's OH, close the brackets, 2. Now this tells us that there are 2 lots of OH attached to the magnesium, and in fact we could draw this one if we wanted. Okay, and we could draw it as OH at this end, attached to the magnesium here, attached to the OH at this end. Okay, and that should help you see that there are 2 oxygens, 2 hydrogens, and 1 magnesium all attached to each other. So this should help you, okay, to work these out. So pause the video whilst you try and complete the rest of this table, please. Okay, so let's go through those. We've already done that. This one is 2, this one is 18, this one's 44. CH4 was 16. NaCl was 58.5. Okay, because we added together the sodium, which we don't have here. We had to use our periodic table to look it up. Sodium's here at 23. We added our 23 to our 35.5, which gave us 58.5. Magnesium chloride, MgCl2, was 95. Okay, we had all the numbers for that here. S8, okay, we had all the numbers for this here, so it's 8 lots of 32, which was 256. Al2O3, well, we needed to look aluminium up in our periodic table, and here it is, with 27. So it's 2 lots of 27 added together with 3 lots of oxygen, which gave us 102. And for our last one, we had magnesium at 24, added together with 2 lots of oxygen at 16 and 2 lots of hydrogen at 1 each. And that gave us 58. So, well done if you got all those right. If you didn't, have a look back and see if you can figure out where you went wrong. Is it just an error with your maths, with the adding up? Or is it an error where you haven't accounted for some of the smaller numbers, or you've not dealt with the brackets correctly? If you have any questions, please do email your teacher, because these are not the easiest concepts. So if you've done even any of these right, you've done really, really well, okay? So don't feel like this is really, really unfair and you don't feel like you can't do it, okay? It started out easy and it got progressively harder and harder, okay? Not everyone is going to get these last few because they're hard, okay? So don't worry if you didn't get them all, but do try and figure out where it was you went wrong so that you can improve and get better. And that's the most important part. Okay, so we're going to move on now to task 3. So task 3. Using the periodic table, complete the table below to show the percentage mass of the compounds. Okay, now percentage mass is written here. Now, this equation is very important. Okay, so percentage mass as a percentage equals the total mass of atoms in the element, the AR, the relative atomic mass, divided by the MR, which is the mass of the molecule, all multiplied by 100. Do not forget to multiply by 100. Whenever I see errors with this, it's almost always they forgot to multiply by 100. Okay, so I get people saying it's 2% or it's 0.2% more likely, when in fact it's 20%. Okay, or they'll tell me it's 0.5% instead of 50%. Or they'll give me a really, really small number. It's 0.0001%, okay, instead of it being 1%, okay? So it's very frustrating when that happens, all right? So what I want you to do is we're going to do some of these together, okay? Now, first off, it's asking for the relative atomic mass. So this line here is exactly the same as the task you did for task 1, okay? So just using the periodic table to find out the relative atomic mass, okay? So that's just looking up hydrogen in the periodic table. The relative atomic mass for hydrogen in the periodic table is 1. Okay, let's look up the relative atomic mass for oxygen in the periodic table. What is it? Or you can use the previous activity. Okay, again, this one wants to know about oxygen as well, so it's the same answer for both of these. Okay, so I'm going to give you a couple of minutes, well, you've got as long as you need really, so you pause the video whilst you work these out and then we'll go through this first line. Okay, so let's go through that. So the relative atomic mass of carbon is 12, hydrogen's done for us, sodium is 23, oxygen is 16, and that's here, and aluminium is 27. So give each of those a tick if you got them right. Okay, that's stage 1 done. Now we're going to have a look at how many are in the molecule. Okay, so it's asking us about each of these molecules. Okay, so this is what this question is asking us, is how many hydrogens are there in H2O? Well, how many hydrogens are there in H2O? Can you think about the answer? There are 2. So the answer here is there are 2 hydrogen atoms in H2O. So how many carbon atoms are there in CO2? How many hydrogen atoms are there in CH4? How many sodium atoms are there in NaCl? And so on and so forth until we get to the end. Remembering that for MgOH2, you multiply everything in the brackets by 2. So try and answer each of those for me, please. Pause the video whilst you do that, and then we'll go through the answers together. Okay, so there is just the one carbon in CO2. Okay, just one. There is one sodium in NaCl. However, there are 6 oxygens here. Aluminium, there are 2 of them as shown by the Al2, same as the 6 is shown by the O6. That more like a 6 there. Okay, and for oxygen here, remember we multiply it by 2, so there are 2 oxygens because the 2 outside the brackets, as you should know from maths, a number outside a bracket multiplies by what's inside the bracket. So there's 2 oxygens and 2 hydrogens there. So here we have our answers. Tick it if you got it right, correct it if you got it wrong, and that's part 2 of this question done. Now, we're going to move on to the next section. Okay, so all this is asking us to do is multiply these 2 numbers that we've worked out. So 1 multiplied by 4 is 4. 12 multiplied by 1 is. 1 multiplied by 2 is, and so on and so forth. Again, remembering that in science you are always allowed a calculator. So please use a calculator if you're not sure. So pause the video whilst you work out what those 2 numbers we've just written in for each column is worth. Okay, let's go through that. So for the first one, it's asking to do 1 times 2. Well, 1 times 2 is 2. In fact, I'm going to show you this version of this so you can see my workings out. Okay, so 1 times 2 is 2. Okay, because there's the 1, there's 2, multiplying them together. 12 times 1 is 12. Okay, and we'll tick them if we get them right. 1 times 4 is 4, we were given that one. 1 times 23, or 23 times 1, it doesn't matter which way around you do it, is 23. 2 times 35.5 is 71. 6 16s, or 16 sixes, is 96. 2 lots of 27 is 54, and 2 lots of 16 is 32. So if you got those right, well done. If you made some mistakes, that's okay, but I want you to look back and figure out how it is that you got it wrong. Where did you go wrong? Was it that you were multiplying incorrect answers from earlier, in which case rewind the video, write in the corrections, which we should have been doing as we go along, okay, and then recalculate it and see if you get it right this time. So now we're going to calculate the MR, or the total mass of atoms, sorry, the mass of the molecules here. Okay, so that is the total mass of the whole molecule. Okay, so the total mass of H2O, the total mass of carbon dioxide. I'm going to go back to this version for that. So the total mass of H2O, and again, we've worked some of this out before. This is exactly the same task as we did in task 2. Okay, where we worked out the total mass, and some of these you'll be able to calculate either fresh again to check you can still do it, or you can just use these ones. So the total mass of H2O, okay, is 18. Well, here we have H2O, 18, because that's what it's asking for. So for carbon dioxide, it's 44. So pause the video and complete the rest of these columns for me, calculating the total molecular mass of each of these molecules for me. Okay, pause the video whilst you do that. Okay, so we're going to go through those now. So for carbon dioxide it was 44. For sodium chloride it's 58.5, 58.5. Chlorine was 95, and again we're just adding up the numbers, so 23 plus 35.5 is 58. Okay, and it's the same as previously, so magnesium plus 2 chlorines is 95. 6 lots of carbon, which is 12 each, 12 lots of hydrogen, which is 1 for each, and 6 lots of oxygen, which is 16 for each, adds up to 180. 2 lots of aluminium at 27, plus 3 lots of oxygen at 16 equals 102. Magnesium plus 2 oxygens plus 2 hydrogens adds up to 58. Okay, so if you've made some mistakes, correct them and figure out how it is you went wrong. Was it a maths thing? Did you not count all of the atoms? Okay, because what's most important here is you figure out where you're going wrong so that you can fix it and not do that next time. Okay, so the last part of this, definitely the trickiest, but we're doing really well so far. So the last part here is calculating the percentage mass. So this is the real question we've been asked all along. So the first part is, what percentage of H2O, water, is hydrogen atoms? Okay, now there are 3 atoms in H2O, 2 hydrogens and 1 water. Now you might think, well, it's 2/3 of it, surely, because there's 3 atoms and 2 of those 3 atoms are hydrogen. No, that's not the case, because you have to take into account this percentage mass. And hydrogen has a relative atomic mass of 1. Okay, so it's got 2 hydrogens, so there's a total of 2 atomic masses of hydrogen in H2O out of a grand total of 18. So 2 out of 18 as a fraction is a 1/9. Okay, so there's a formula for this. It's the formula above the table. Percentage mass equals the total mass of the atoms, the AR, divided by the mass of the molecule, MR, multiplied by 100. So we've worked these out. So it's the AR, which is the total one, so it's 2, divided by 18, it's going to multiply by 100, it's going to give us our result. So let's write that in. I'm going to do it in this pen because it's much thinner, I can fit it all in. So 2, which is our AR, divided by 18, which is our MR, all multiplied by 100 equals 11% using a calculator. Okay, I'm not expecting you to do this without a calculator, okay? Because you will make mistakes. In science, we ask you to use a calculator wherever you need to do any calculations because it's more likely to eliminate mistakes. Please do check your answers, okay, but check that they're sensible. But you do need to use a calculator for these because otherwise you'll have problems, because quite often, maybe not for this question, but for most of them, you will find that actually, well, this one was 11.11111 recurring. So that's 11. We're going to round our numbers up or down appropriately, remembering that if you have a number that is, say, 37.5, you round up to 38, or you can just put 37.5 in. If you have a number that is 37.49, you round down, okay, to 37, or just 37.5. Okay, if you want to do it to 1 decimal place, that's absolutely fine. Please don't put any more than 1 decimal place in these answers. Okay, so reminder of what to do before you go ahead and do it yourself. You take your atomic mass, okay, of the element, divide it by the molecular mass of the whole molecule. So this one divided by this one, multiply it by 100. So 12 divided by 44, multiplied by 100. And I want you to write it out like this if possible. If you haven't got a space, feel free to use the working out area at the top of this page, or student notes page, or scrap paper. I don't mind where you do that. So pause the video whilst you do these. This might take you a little while, but that's absolutely fine. Okay, let's go through those then. So, we've already done the first one. The relative atomic mass, the percentage mass even was 11%. So the percentage mass of carbon in carbon dioxide is 27%. It's done this one for us, so the percentage hydrogen mass in CH4 is 25%. The percentage mass of sodium in sodium chloride is 39%. The percentage mass of chlorine in magnesium chloride is 75%, or 74.7 if you've put it to 1 decimal place, that's fine. Okay, so either of those answers is acceptable for the mark. But if you've put 74, you would not get the mark because you didn't round it appropriately. Next one. So the percentage mass of oxygen in C6H12O6 is 53%. The percentage mass of aluminium in Al2O3 is 53%, or 52.9%. Again, if you've written 52%, you would not get the mark because you did not round appropriately. And the last one, the percentage mass of oxygen in MgOH2 is 55%. So if you've got all of those correct, well done. That was a really tricky task, and I'm really pleased with how well you've done. If you didn't get them all right, put the corrections in, show the calculations, and try and figure out where you went wrong. Is it because the numbers you used before were wrong? Is it because you forgot to multiply by 100? Is it a rounding error? Did you forget to round properly? Okay, did you mix up the order of the numbers? What is it that went wrong? Pay attention to that so that next time you do it, and you'll be doing it this lesson, so next time you do it, you'll do it correctly. Okay, so we're going to move on now. So percentage mass of molecules. So this is literally what we've just been doing. So sometimes we need to work out the mass of a molecule as a percentage, which gives an idea about how much of the molecule is made from a particular element. And it's this equation here, which we've just done and just used, okay? So it's all about telling us how much of the molecule is made from a particular element. That's all that is, okay? So counting atoms and molecules. Now, this is actually higher tier content. So all we need to do for this is put next to it higher tier content. Okay, so if you're a higher tier student, you can skip forwards to the knowledge and application check, okay, and complete those questions. Okay, they will be reviewed at the end of this lesson, and foundation tier students can skip questions 8 and 11. Okay, so if you're a foundation tier student, don't worry about question 8 and question 11. Okay, and that will be found at the end of the lesson. You will need to fast forward to that point in the lesson. So back to our higher tier students. The rest of the lesson content is for you. So, all about counting atoms and molecules. The fact that atoms are so small means it would be impossible to measure the mass of just one atom. So what we do is we measure lots of them together. Okay, so we need to measure lots of them together in order to use measurements that we can, such as grams. Okay, the quantity of atoms or molecules that we actually measure is this big number here. Right, let's highlight this. This big number here. It's a 6 with 23 zeros on the end. I'm going to write it out beneath here, nice and large. It's 6.02. Don't worry too much if you forget the 02, times 10 to the power of 23 atoms. Okay, that is 1 mole. So this here is really essential knowledge for higher tier students, and you need to know that. Okay, so that's how many atoms are in a mole. Sometimes we use the symbol for the unit, which is MOL. So it's the same word minus the E on the end. A mole is just the name for the number, just like a pair, a few, a dozen, okay? You can have a mole of anything as long as you count 6 times 10 to the 23 of them. So how can we count a mole of atoms? Well, we simply measure the relative atomic mass in grams. So 1 mole of atoms is equal to its relative atomic mass in grams. Okay, and it's really easy. Okay, so each element has atoms that are different sizes. That's really important to know. Okay, the further down the periodic table they are and the further to the right they are, the bigger the atom, most of the time. So when we count a mole of atoms, the total mass is always different. And that's for each element. This also applies to compounds because they're made up of different atoms in different arrangements. Okay, but we have to calculate the mass of the compound first. So, for example, hydrogen has a relative atomic mass of 1, okay, because it's an element. So the mass of 1 mole of hydrogen is going to be 1 gram. Same goes for lithium. The relative atomic mass is 3, so its mass of 1 mole is 3 grams. And you can see this repeats, and that's the same for every element in the periodic table. Now the same idea happens when we start to look at compounds. H2O, we do the MR, the relative molecular mass, which is just adding up the relative atomic mass of the compounds. So hydrogen, it's 1 each, so that's 2, plus the 16 for oxygen, gives us a total of 18, meaning that 1 mole of water is 18 grams. If you go and use your scales to measure 18 grams of water, that is 1 mole of water. You might want to measure 10 moles of water, 180 grams. As long as your water is pure, which it won't be if it comes out of tap, but if your water is pure, that 18 grams is exactly 1 mole of water. Okay, and the same goes for carbon dioxide, methane, and magnesium chloride. Okay, so the relative molecular mass is also the mass of 1 mole if you add G for grams on the end of it. So what I'd like you to do now, and this is still for higher tier students only, so you're going to watch this clip here, okay, you're going to make some notes on your student notes page, again it's page 12 or on a separate page, don't mind where, okay, about what a mole is and more importantly, how to use the moles formula. Okay, so pause this video whilst you go and watch the YouTube one. Again, if you have the digital copy of this, then you'll be able to click on the link. Okay, welcome back. So, this learning activity, calculating moles. Okay, so it's really easy. It's very much the same as what we've just done. So you're going to use the periodic table to find out the relative atomic mass, okay, which if it's compound, you just add together the total relative atomic masses and then convert the number to grams. Okay, very similar to the little table above. Okay, so same idea. So for hydrogen, the relative atomic mass is 1. Okay, and so the mass of 1 mole of hydrogen is going to be 1 gram. That is literally it. So let's do sulfur. Sulfur, the relative atomic mass of sulfur is 32. So 1 mole of sulfur is going to be 32 grams. It really is that easy. Okay, and then with compounds, okay, you have to make sure you account for the number and different relative atomic masses. So let's have a look at, I'll leave you the simple one, let's have a look at Cl2, okay, another fairly simple one. So the relative atomic mass of chlorine is 35.5, I'm going to write my calculations in pen, and there are 2 of them, so it's 2 lots of chlorine, which is 35.5, gives me a grand total of 71, which means the mass of 1 mole of chlorine as a gas is 71 grams. Okay, so continue to do that. You know how to calculate the relative atomic mass, you know how to calculate the relative molecular mass, and all you need to do is write the number again with grams after it to give you the amount of 1 mole as mass. Okay, so pause the video whilst you do that, please. Okay, so let's go through our answers. So we have our results here, so make sure you tick each one to show you got it correct. So they should be the same number, but with G on the end, lowercase g, to produce the mass in grams. So for this one, we did 2 ourselves, so 2, 4, 6, 8, 9, so it's out of 7, so 14 then. So give yourself a mark out of 14. Okay, so give yourself a mark out of 14 for these. We did 4 of them ourselves as a group. Okay, then we're going to do this one where we only did 1 example with the chlorine. So we've already done this one. Okay, so 58.5 for sodium chloride, meaning that the mass as a mole is 58.5 grams. 256 for 8 lots of sulfur. 102 for Al2O3. 17 for NH3. MgOH2, 58. And C6H12O6 is 180. Okay, and you get a mark for writing it with G afterwards for a mole, and a mark for writing it without as the relative atomic mass, sorry, relative molecular mass. So for this one, we've got 1, 2, 3, 4, 5, 6 that we did on your own. So give yourself a mark out of 12. Okay, so well done. Okay, don't worry if you got struggled on a few of them, especially these ones at the end. They're quite tricky. Okay, do try to figure out where you went wrong, again, so that you know where to be careful next time. I'm going to move on now to the next activity. Okay, so here we have an extension activity, okay, but if you are a higher tier student, really you need to be able to do this. In fact, for a higher tier student, this is not extension activity at all. This is really quite essential. So we're going to do an example. I'm going to do magnesium because I think that's a really good idea to do for our example. So magnesium has a relative atomic mass, because it's an element, not a compound, of 24. Just like lithium has a relative atomic mass of 7. So the mass of 1 mole, just like lithium, it's 7 grams. So magnesium is going to be 24 grams. Okay, same number, just with a G afterwards. Now the mass of half a mole, 0.5 a mole. So we're going to divide our number in half, divide it by 2. So for this one, that gives us 12 grams. Then this time we want to know 2 moles. So it's going to be our original number for 1 mole, multiply it by 2. It's going to give us 48 grams. And then the mass of 10 moles, we'll take our original number and multiply it by 10, which just means add a 0 on the end, which is going to give us 240 grams. Okay, so that's all you need to do. Okay, so I want you to complete the rest of these tasks, remembering that for these you've got to add together to get the relative molecular mass. Okay, so pause the video whilst you do that, and then we'll go through it. Okay, so let's review those then. So hydrogen had a relative atomic mass of 1, so 1 mole is 1 gram, half a mole is 0.5 grams, 2 moles is 2 grams, and 10 moles is 10 grams. Okay, helium has a relative atomic mass of 4, so we've got 4 grams, 2 grams, 8 grams, and 40 grams. Okay, sodium chloride had a relative molecular mass, because we had to add them together, of 58.5, giving us 58.5, and it gets tricky here. Half a mole is now 29.25 grams, or 29.3, I will accept it to 1 decimal place. 2 moles is going to be 117 grams, and 10 moles 585 grams. NH3 is 17 for its relative molecular mass, meaning that it is respectively 17 grams, 8.5 grams, 34 grams, and 170 grams. Chlorine has a relative molecular mass, Cl2, of 71, giving us 71 grams, 35.5 grams. If you've rounded to 36, that's fine. Same with this one, if you've rounded to 9, that's fine. It's better if you do it to the nearest half a gram though. 142 grams and 710 grams. So we did magnesium together, leaving us 25 marks available. Give yourself a mark out of 25 for that, please. Okay, so again, it gets a bit tricky with the maths. You're always allowed to use a calculator in science. Please don't forget that. And here is the equation that you can use to do this. Okay, it's not really essential, but I will let you make sure you know it. So mass in grams is the relative atomic mass or the relative molecular mass, depending on whether it's an atom or an element or whether it's compound, multiplied by the number of moles you're looking for. So that's exactly what we have just been doing. Okay, we calculated our relative atomic masses and relative molecular masses, and we multiplied them by 1 mole, half a mole, 2 moles, and 10 moles. And that's what we were doing. This is an equation that shows that. So lastly, before we do our knowledge check, we're going to move on to page 10 with a checkpoint question. Now, this is a tricky question. It is worth 5 marks. Okay, and I want you to feel free to look back through the booklet and follow the steps that we have done. A glass contains 232 grams of water. Okay, remember the chemical formula for water. Estimate the number of water molecules in the glass. So it wants to know how many there are. So how many water molecules is 232 grams? Give your answer to 3 significant figures. And it tells you that the relative atomic mass of hydrogen is 1 and oxygen is 16. Okay, so pause that and have a go at the question and see how well you do. If you get completely stuck, you can play it and I will show you a hint of what to do next. Okay, and then you can, hopefully that will help you. Okay, so sometimes it can be really tricky to get started on a question like this. So the first thing to do is start thinking about what information you've got and what you can do with it. So something you can definitely do here is work out the relative molecular mass of H2O. what is that? You need to work that out. Then there's an equation we used earlier. So the mass in grams is equal to the relative molecular mass or the relative atomic mass, either of those, multiplied by the number of moles. Okay, so this equation is useful, but we have the mass in the glass and we can work out our relative molecular mass. So we need to know this one, number of moles. So we're going to have to rearrange it so that this is the subject of our equation. So number of moles equals, can you rearrange these two so that this is number of moles in the glass equals, and rearrange the equation so you can put the values in for these. Okay, so you need to finish the equation here and use that to help you out. Okay, then lastly, if you got stuck on the last bit and you know how many moles are in the glass, well, you need to remember that 1 mole is 6.02 times 10 to the 23 atoms, or a 6 with 23 zeros after it. Okay, and that will help you because if you know how many moles are in the glass and how many atoms are in 1 mole, you can multiply those two together to tell you exactly how many atoms are in that glass. Okay, again, you'll need a scientific calculator to do this. So now that you've had some hints, feel free to pause the video again and continue on, and then we'll go through the answer. Okay, so let's go through that. The relative atomic mass of hydrogen is 1, so H2O has 2 atoms of hydrogen. The relative atomic mass of oxygen is 16, and H2O has 1 atom of oxygen. So that's how we work out that the relative molecular mass of H2O is 1 plus 1, or 2, plus 16. So it gives us 18. And you get a mark for working out that the MR of oxygen is 18. Okay, now the mass of 1 mole of H2O is 18 grams. You could have used that to work it out. Okay, but there's no marks for this. The only mark is to work out that oxygen has an MR of 18. Zoom that in so we can see that more clearly. Okay, so then here's the equation that I gave you. The mass is equal to the MR multiplied by the number of moles, but it's not useful until we rearrange it so that the number of moles equals to the mass divided by the MR. Again, still no marks until you put the values in. So if you've worked out that if you've done 232 divided by 18, anywhere on your page you can have a mark for that. Okay, 232 divided by 18 will give you a mark. The next thing is if you've worked out the answer to that is 12.89 or 13 or 12.9, any of those, then you get another mark. So this number, but you can have it rounded, that's fine. Okay, so we're doing really well so far. We've got 3 out of 5 marks. The way to bring it home is to know that the mole is this number of atoms, okay, and to work out that if you've got the number of moles of water in the glass, and that's how many atoms in the glass in each mole, you can multiply these two together. So number of atoms in the glass is the number of moles, this one, multiply the atoms in a mole, this one, okay, so 12.89 from our previous answer, multiply by 6 times 10 to the 23 atoms. So if you've multiplied 12.89, or your answer here, by this 6 times 10 to the 23, then you get a mark. That's the 4th mark. And the 5th and final mark is for saying, or finding the answer to that, which is that the number of atoms in the glass is 7.76, because we're doing this to 3 significant figures, multiplied by 10 to the power of 24 atoms. Now, if you don't do this to 3 significant figures, then you don't get the mark. Now, your answer will be slightly different if you've rounded 12.89. Ideally, don't do the rounding till the end. Okay, if you've used slightly different numbers, okay, but your answer for the moles, which should be 13 or 12.9, or whatever your number is for here, as long as this answer is definitely this number multiplied by this number, then you can have the mark for this answer. So that is out of 5. Okay, if you got all 5 marks on that, you should be so proud of yourself because that is really, really hard. Okay, but you can see that even for just doing the relative molecular mass of water, you still get a mark. Okay, and then for working out the number of moles in the glass, you will get another 2 marks. So each step of the equation or each step of the question gets you more and more marks. So even if you didn't get all the way to the end, you've done really well just by doing any part of it, and every mark counts in the exams. There are so few marks between grade boundaries that every mark is essential. So well done. We're going to skip to the last part. We're going to move to the last bit of the lesson now. knowledge and application check. Again, remembering if you're a foundation tier, skip question 8 and 11. If you're a higher tier, you will need to do all of them. For some reason, when we get past question 8, the numbers on this are missing, so don't worry about that, just fill them in yourself so that we know which questions we're on about. So pause the video whilst you work through those, and then we'll go through them together. Okay, so let's review. Question 1. Name the subatomic particles used to calculate atomic mass. That is protons and neutrons. You need both for the answer, and please make sure you're marking a different coloured pen to the one you used to answer the questions. Question 2. Name the subatomic particles found in the nucleus. Well, it's also protons and neutrons. Question 3. Write the symbol for relative atomic mass. That's a large capital A, okay, and a lowercase or subscript, in fact, R. Okay, so to make that really clear, it's not AR like this. That would be wrong. It is AR, and the R is below it, like so. Okay, so if yours isn't clear, please rewrite it correctly. Okay, give the units for percentage mass. Well, it's a percentage. Question 5. What is a compound? Define it. A compound is 2 or more atoms chemically bonded together. Make sure you've written that definition as it is, if in case yours is different. Question 6. Write the symbol for relative molecular mass. Again, this is a capital M and a subscript R. So not Mr. like this, that is not correct. M and a lowercase subscript R like so. So it's literally partially below the M. Question 7. Give the units used to measure mass, grams or just a lowercase g. Question 8, this is a higher tier question. Give the value of a mole. Well, it's 6.02 times 10 to the 23. If you've written atoms, great, but you don't need the atoms part for the mark. Question 9, calculate the relative molecular mass of sulfuric acid, H2SO4. Well, we've had to add all the different parts together. So 2 lots of 1 for hydrogen, 32 for the sulfur, and 4 lots of 16 for the oxygens. Gives us 2 plus 32 plus 54 gives us 98. Okay, whether or not you've showed your working, you still get the mark for this answer. But if you're asked this question in an exam, please do show your working out, because sometimes there are marks for that, okay? Question 10. Question 9. If you got that wrong as well, please show the working to show how to get the mark correct, and that'll be able to help you figure out what's been done there. And you can use your periodic table to help you understand where these numbers have come from. Okay. Question 10. Calculate the percentage mass of sulfur in sulfuric acid, which is H2SO4. So, sulfur is the S here. So, 32 is the relative atomic mass of sulfur, divided by 98, the molecular mass of sulfuric acid. All multiplied by 100 gives us 33%, or 32.65 or 32.7%. Either of those is fine. Okay, so any one of those 3 answers will give you the mark. If you got it wrong, make sure you write out the full answer, not just the final part of the answer. Question 11 is a higher tier question. Okay, calculate the number of moles and 64 grams of sulfuric acid. Okay, so you need to know the relative molecular mass of sulfuric acid, and that's 98. Okay, so you can have a mark for that part. And so that makes 98 grams for 1 mole. The number of moles is the mass divided by the relative molecular mass, so it's 64 divided by 98 gives us 0.65 moles. Okay, so if you got it wrong, then make sure you write down each of these steps here to show how it was worked out, so you know what to do next time. So if you are in the foundation tier, okay, you'll need to give yourself a mark out of 9. If you are a higher tier, there were 11 questions, but question 11 had 2 marks for it. So you give yourself a mark out of 12, please. Okay, so if you got less than half marks, okay, so 4 or less for foundation tier, 6 or less for higher tier, then you need to review this content and have another go at some of it. Identify where you went wrong, identify whereabouts you went wrong and what part of the lesson that is, and review it, please. If you're not sure or you're stuck or you want some help to explain things further, please do email your teacher and they'll be very happy to help you. Okay, and that concludes the end of our lesson. Thank you very much.